Assalamu alaikum and good morning, everyone. We are here to present our project. Our project title is IoT-Based Smart Energy Meter. I am Protyojit Shaha. My team members are Famia Akhtar Farah and MD Moshur Rahman. Today, we will explain our project step by step. First, I will discuss the introduction, motivation, and objectives. Then, my second team member will explain the system components, circuit connection, and working procedure. Finally, my third team member will explain the prototype, output, limitation, and conclusion. Now, I am starting with the introduction. Electricity is very important in our daily life, but many people cannot monitor their energy consumption in real time. Usually, we only know the total electricity bill at the end of the month. Because of this, users cannot easily understand how much energy is being used by a load. To solve this problem, we developed an IoT based smart energy meter. This system can monitor voltage, current, power, and energy consumption. It can show the values on an LCD display. It can also send the values to the Blink mobile application through Wi-Fi. In our prototype, we used a low voltage DC load for a safe demonstration. We used ESP32 as the main controller. ESP32 collects sensor data, calculates power and energy, and sends the data to the Blink app. The main motivation of this project is to make energy monitoring easier, smarter, and more user friendly. With this system, users can monitor energy use from anywhere using a mobile phone. Now I will explain the objectives of our project. The first objective is real-time monitoring. This means the user can see voltage, current, power, and energy values instantly. The second objective is remote load control. Using the Blink app, the user can turn the load on or off. The third objective is to develop a low-cost system. We used common and affordable component. The fourth objective is energy awareness improvement. When users can see energy consumption, they become more careful about electricity use. So this is the basic idea and objectives of our project. Now my second team member will explain the system components and working procedure. Thank you.
Thank you, Protyojit Shaha. Now I will explain the components and methodology of our project. The main components of our project are ESP32 microcontroller, ACH712 current sensor, relay module, 16 by 2 I2C LED display, DC LED load, power supply module, jumper wires, and breadboard. The ESP32 is the brain of our project. It reads sensor data, processes the data, controls the relay, and sends information to the Blink app. The ACS712 current sensor is used to measure load current. It is connected in series with the DC load. So, when current flows through the load, the sensor can detect it. The relay module works like an electronic switch. It is used to turn the load on or off. The relay is controlled by ESP32 and also by the Blink mobile app. The LCD display is used for local monitoring. It shows voltage, current, power, energy, and online or offline status. Now I will explain the connection procedure. First, we connected the LCD display with ESP32 using I2C communication. The SDA pin of LCD is connected to GPIO 21 of ESP32. Then ACL pin of LCD is connected to GPIO 22 of ESP32. Then we connected the relay module with ESP32. The relay signal pin is connected to GPIO 25. When ESP32 gives signal to the relay, the load turns on or off. Then we connected the ACS712 current sensor. The output pin of the current sensor is connected to analog pin GPIO 34 of ESP32. ESP32 reads this analog value and calculates current. In our code, the voltage is fixed at 4.5 voltage because we are using a DC load. Then power is calculated using the formula. Power equal voltage multiplied by current. Energy is calculated using power and time. Now I will explain the working procedure. When the system starts, the LCD shows a starting message. Then the relay is turned off for sensor calibration. During calibration, there is no load current. So ESP32 can detect the zero current value of the ACS712 sensor. This helps to improve current measurement accuracy. After calibration, the relay turns on and the DC load start working. Then the current sensor measured the load current. ESP32 calculate voltage, current, power, and energy. The calculated values are shown on that LCD display. At the same time, if Wi-Fi is connected, the values are sent to the Blink IoT platform. The Blink app has virtual pins for voltage, current, power, energy, and relay control. So we can monitor the data and control the load from the mobile app. This is the methodology of our IoT-based smart energy meter. Now my third team member will explain the prototype type output, limitation, and conclusion. Thank you.
Hello everyone, Assalamu alaikum. Hope you are doing well. I'm MD Moshiur Rahman. Now I'm explaining the part of prototype, output, limitation, and conclusion. On the right side, we place the ESP32 board. Below the ESP32, we place the LCD display. On the left side, we place the DC LED load and power supply section. We also use a relay module and ACS712 current sensor for load control and current measurement. When the system is powered on, the ESP32 starts running the code. First, it calibrates the current sensor, then the relay turn on and the LED load start glowing. For example, the LCD shows voltage as 4.5 volt. It also shows current, power, energy, and online status. If Blink is connected, the system shows online status. If Blink is not connected, the meter can still work locally using the LCD display. One important feature of this project is remote control. Using this Blink mobile application, we can turn the load on or off. This makes the system more flexible and user-friendly. Now, I will explain the limitation of our project. First, I will show the control using mobile and PC use of Blink IoT. When we turn off the switch, that time our relay is off and our load is also turned off. And we can also use mobile phone for controlling or monitoring using Blink IoT. You can see now I will explain the limitation of our project. The first limitation is that this system is designed for low voltage DC load testing only. The second limitation is that voltage is fixed in the code. So variable voltage measure is not included in this prototype. The third limitation is that current measure accuracy depend on proper ACS712 sensor calibration. The fourth limitation is that Blink remote monitoring required a stable Wi-Fi connection. The fifth limitation is that long-term data logging and monthly report generation are not included. Also, advanced safety feature like fuse protection and enclosure design are not fully implemented. So, this project is mainly suitable for academic prototype demonstration, not for commercial billing use. Now, I will include our presentation. In the future, this project can be improved by adding variable voltage measurement, data logging, monthly report, and better safety protection. That is all about our project. Thank you everyone for listening to our presentation. Now we'll ready for question.
Why did you use ESP32?
Because it has Wi-Fi and work well for IoT project.
What is the main purpose of this project?
To monitor energy consumption in real time and uh, see how to control our load using mobile app or website browsing in our computer.
What is the main function of the relay?
It's turn the load on or off.
Which microcontroller is used?
ESP32 dev module. Mr. Potojit Shaha, can I ask
Yes.
you some questions?
Yeah, obviously. For safe and easy demonstration,
What is the formula of power we use in this project?
it's very simple. Power is equal to voltage into current.
Can this system work without internet?
Yes, it can show data on LCD without internet.
It is very interesting part. We can use offline.
Is it suitable for commercial building?
No, it's only an academic prototype.
Can you please tell me what is the future improvement?
Add variable voltage measurement and data logging can be improved this system.
Famia, what is IoT?
IoT means controlling and monitoring device through the internet.
Thank you. Can I stop this presentation?
Yeah, of course.
Yes, you can.
Okay. Thank you.